Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome back to our course. In this lecture, we are going to build our level, our first level for our project. For our platformer game, we're going to need a different level from this existing one. And you can also create more levels if you don't want to have just one. Or you could also just have one level, but then have it restart every time the player finishes the level, and then rearrange or procedurally generate the objects in the level to make it a different version of its previous iteration. For our purposes, let's get started making a new level. To create a new level other than this default one, we are going to go up to our header here at File, and we're going to select New Level. Okay, then we're going to be able to select from different level types. We have default, time of day, VR, virtual reality, and empty. Let's select default. In a default level, we have a floor here, and you can go to the world outliner to see all that you have. So other than the floor, you also have atmospheric fog, a light source, otherwise the game would be black, a player starting position, a sky sphere, skylight, and a sphere reflection capture. All right, so we can save this level by hitting Control or Command S, and here we can save it inside of a new folder. We want to keep our folders separate, so let's just right click and create a new folder that we will call Levels. Then double click to enter that. Then we can see in the bottom left hand corner our path, and let's call this Level 1. A level is also called a map. Then hit enter or save, and now we have a name for our level. It's level 1. Okay, so if you hit play, which is typically in the center of your window here, in my case it's on the side because I've zoomed in my text size. Okay, but here you can press play and you can test out the level. Click inside of the viewport for mouse control. Okay, and you can look around the level, and you can also move around with your WASD keys and your Q and E keys, and in this case you're moving the camera. Alright, so there we go. If you want to stop the game, just press the escape key at the top left hand corner of your keyboard. Alright, so just like this we have a new level. We can already change properties of the level, such as, for example, the floor. And here, by the way, I'm moving around just by clicking and holding my left mouse button and then moving my mouse around. Or you can also click and hold the left mouse button and then use the WASD keys and the Q and E keys to move around. Okay, so here, let's take a look at the floor. All right, and let's give it a different color. So if you click on the floor in the viewport, that will also select it in the world outliner window. Then you can click on the details window, and you can see we have different components of our floor. We have a transform component to set location, rotation, scale, and more. We also have a static mesh component, which is what draws the geometry or mesh of the object. We also have materials, which gives color and texture to our object. In this case, the element has the material of default material, but if you change this to something like basic floor, look at that. The color of the floor has now changed. Okay, it's now this default color, which is this gray blue. All right, and just like that, we have changed a property of one of the objects in our level. And we've also saved this new level. Next up, now that we have our level, we need to create a player, because even though when we hit play, it looks like we are being able to move around and look around the game, this is actually the camera. So I want to create a separate object, a separate blueprint for my player. So join me in our next lecture where we will build a player. Hello everyone, and welcome back to our course. In the previous lecture, we learned how to create a new level for our game. We also learned how to move around in our viewport and in our game. And we edited the material of the floor. Next up, we are going to build a player blueprint for the game. First, let's navigate to our content browser where we now have two folders because in the previous lecture, we created a levels folder. And here, let's go into the content main folder and let's create a new folder because you want to stay organized. With games, the bigger your game gets, you can quickly have a lot of different files. So you want to stay organized. Here, I'm going to right click and create a new folder, or you can also press the add button here in the top left-hand corner of this window, and you can select new folder. We're going to call this our blueprints folder. All right, and this is going to store all of our blueprints. If you're familiar with programming, a blueprint is like a class or an entity that describes an object. For example, you could make a blueprint to describe a player or an enemy or food or an object. So we use blueprints to create classes with visual scripting. And a blueprint lets us represent an object and give it functionality and logic. To start off, we're going to create a blueprint to represent our player. So let's double click inside of this blueprints folder to enter it. And then we're going to create a new blueprint. All right, so I'm going to press the add button again. This time I'm selecting blueprint class from this basic asset section. So click blueprint class and you will have several options as well as even a drop-down menu to select even more. There's quite a few types of classes that are pre-built by Unreal to help you build your blueprints faster. We can start by looking at these top few, but then there are many more classes as well. We have an actor, which is an object that can be placed or spawned in the world. We have a pawn, which is like an actor, but it can also receive input from the user or the player. We have a character, which is like a pawn, but it can also move around. We have a player controller, which can control a pawn used by the player. A game mode base, which is like a game controller to manage the whole game. An actor component, which is like a leg or an arm that you can add to an actor just so you can have multiple components working together. And a scene component, which has a scene transform and can be attached to other scene components. Then under all classes, we actually have even more blueprints, so there are quite a few to choose from. For our player, though, let's think about what we want our player to be able to do. Do we want our player to receive input? Well, yes, we do. So let's select pawn. We could select character to walk around, but we're going to be walking around with user input, and I'll show you how to set that up shortly. Then let's give this blueprint a name. We'll call this our player_BP. You'll commonly see BP at the end of a name of a blueprint, just per convention, but it's not required. Okay, and I can expand this out so we can see all of our contents. So now we have in our blueprints folder a blueprint called player BP. If you double click on this, you will open up the editor for that blueprint. And don't forget to save your game often with Control-Shift-S or File and then Save, or better yet, File Save All to save all of the unsaved levels and assets in the project. Okay, so here we now have our blueprint open. This blueprint has several of its own windows. Okay, so first in the center here, we have our viewport, which shows the contents of the blueprint. A blueprint can have meshes and visuals and geometries inside of it. So you could have a player character that is visual, and then it actually is part of the blueprint. You also have a construction script and an event graph. The event graph is where you will write your functionality for what you want the blueprint to be able to do. Then as well, we have three tabs on the left-hand side: details, which tell us the details about any item inside of the blueprint. We have components, where we can add visuals and collisions and more to this blueprint. So you can select from these pre-built components. And we have my blueprint, which describes the whole blueprint and it allows you to add more variables and functions and more. A variable will store data. It's a way to represent a piece of data like the score or the health or the XP of a player. A function performs some kind of task, like it kills a player or restarts a level. We have here some graphs, and inside of our event graph, we have 3 events already existing. Event begin play, our event actor begin overlap, and our event tick. Okay, we can see those 3. And to move around in this event graph, just right click and hold and then drag around, okay? And if sometimes you have trouble moving around, just make sure you have your blueprint saved and compiled, and then you can move around. Okay, and we have some functions. By default, we'll have a construction script function created. All right, but you can close this. There's no content inside of it. Functions allow you to split up your tasks. So you don't have just a huge blueprint full of tasks, but instead you can split off different tasks into functions. We also have macros and variables. Variables allow us to store data. It allows you to store a piece of information in memory. And we have events. All right, so now we have our player blueprint created. Let's start by giving our player the ability to move around based on user input. To enable that from scratch, we are going to add a new component to the player blueprint. So open up the components window here. All right, and here we can see we have the player blueprint self. It just refers to this blueprint. Then we have one component already, the default scene root component. This just refers to our default root of the actual blueprint, but it's not an actual object that's rendered or seen in the game. It's just a default container. Okay, let's add in a new component by pressing this add button. Here we have several options that we can choose from. All right, I'm going to search here for floating pawn movement and hit enter. Then hit enter again to add the object to your blueprint. You'll notice here, as soon as you make a change, the compile button will change to this yellow question mark, which means you have to recompile if you want the changes to be affecting the game. So just hit compile, and then also if you notice an asterisk beside your blueprint name, it means you have to save your blueprint. It's unsaved, so just use the keyboard shortcut for saving all or saving one. We can also close the compiler results. This is just telling us whether we were successful or not in performing some action. But we can close that for now, and we can always open it back up by using the window tab. Okay, so now we have a floating pawn movement. This is going to help us with moving around our player based on user input. Before we do that, I also want to give our player some visual, because how do we know that we're moving something unless we have a visual for it? Because this game is not going to be a first-person game where you are the camera. This is going to be a platformer third-person game. So that means that we're looking at the player that we're representing. Okay, so for that, I'm going to have to give some kind of visual to my player so I can see where I am. For this, hit the add button again in your components window. And this time, we're going to add a static mesh to this blueprint. So hit static mesh and then hit enter again. All right, now you'll notice here it went by default as a child of the default scene root, and that is fine. Feel free to hit compile. And actually, if you look inside of your viewport, you'll notice you have this new object created, okay, but it's this white circle. It doesn't really have any actual content. I'll show you how to give it some content shortly. To give this static mesh some visual, just go to the details window, and then here you'll notice we have different components and properties of our mesh. All right, what I'm interested in is the static mesh field here, which currently is none. That's why we're not seeing any object appear or any geometry. Instead, select from this drop-down window a shape that you want to represent your player, for example, a cube. And look at that, a cube is going to be rendered in the blueprint, which means our player is now a cube. You can choose from any objects in this list, or you can even add your own files, for example, FBX files, to use your own models. You'll also notice that the player has this default material on it, M basic wall. You can also change that if you'd like. And you can create your own material as well if you want to assign your own color or your own texture to your cube. For now, let's just start with this default white color. Again, we can compile and save our blueprint. All right, so there we go. We now have something that actually represents our player. We can make this smaller just by clicking on the scale tool and then using these different arrows and reducing the scale of our cube. You can click on this center cube and then move your mouse in order to resize the cube. Or you can also use one of the arrows to resize the cube on just one axis. You can also scale this cube by going into the transform property in details, and then you can change the scale. All right, so now we have scale enabled and also color on our mesh. So we still have a static mesh, it just is a cube geometry. Let's also enable our cube here to have gravity, because currently if we add this blueprint to our game, we won't actually have physics enabled. Let me show you what I mean. I'm going to just click and drag this blueprint away. Let's see, or I could just close it for now. And if we hit play, all right, I'm going to go to play. We don't actually see our cube around here. So first you have to add it from your blueprints folder. Just click and drag the cube right into the game. Then if you hit play, you can look around for that cube. There it is. Currently it's on the floor, but if you actually start it from this position at the top and then you hit play, look at that. You'll notice the cube will actually be hovering because it doesn't respect gravity by default. So if you want to force the cube to respect gravity and physics, then double click on the blueprint to open it again and go to the components and select the static mesh again, and then switch to the viewport window to see that cube. And let's give it physics. So we are going to look for the property here that is known as physics. And we're going to select simulate physics. This means that our object will respect gravity. Okay, and as well, we are going to select here some constraints. If you don't want your player to move on one axis or you don't want it to rotate, then you can lock those. It's typically more with things like a sphere, which could roll on its own if it has physics enabled. We also want physics if we want to be able to jump. Also, let's go into the collision property here, and let's select this checkbox that says simulation generates hit events. This means that a hit event should fire when this object collides during physics. This means that we will be able to process collisions on this player because we do want our player to be able to collide with things. In this case, it will collide with a target, which means it has completed the level. But you can also collide with coins, with a death zone, which we'll do as well, with enemies and other players and other objects and more. So you want to be able to generate a hit event so you can specify what you want to happen upon a collision event. All right, and now if we compile and save this, we are going to have gravity enabled. So you can close your player blueprint and you can move your cube anywhere you like. Just keep it above the ground. So that way you'll see when I hit play this time, look at that, my cube actually fell to the ground. And you'll notice here I always spawn in the same position. That's because that is the default setting. You can go here into the 3 ellipses, or the ellipses that are typically beside play, which is just to extend the play tab here to see more about play. And you'll see the default player starting position is default player start, but you could change this to current camera location, which means that wherever I move, that's where I will start when I hit play. You see, there we go. Now I start wherever my camera is. All right, so here we go. We now have our cube respecting physics. All right, so we've created our blueprint. As well, inside of this cube, we can go back to components and we can make this static mesh the default object. We also have a floating pawn movement, and that's fine. It doesn't have to be a child of the static mesh or anything. We just replace the default scene root with our static mesh. So this is now just taking over that default object. All right, now that we've created a player, next up, let's create a camera. So this way we can specify our own camera that can follow the player around. All right, so join me in our next lecture where we will continue this project. Hello everyone, and welcome back to our course. In the previous lecture, we built out a player blueprint. The player is represented as this cube. And next up in this lecture, we're going to build a camera that will follow the player. And later, we're going to enable user input as well. All right, so let's double click on the player blueprint in order to open it up. Here in the components window, we're going to add a new component. This is going to be a camera component. So hit enter, and here we go. Now we have our camera. Now we can also move the camera to be a child of our static mesh. By default, it already is. Great. Okay, so we can make sure to compile and save this. You'll notice currently the camera is right up to the cube, but we want to move this. Let's move our camera back. So we can go into our details window and then use the transform property here. I'm just going to move it back and also up. So we're going to have this top-down view from the camera down onto our player. So let's set this to -600. Let's do 0 and let's do 600. Okay, so now our camera is up top here. We also want to rotate it so it will look down. So let's rotate it by 300 degrees down. Okay, so now it's pointing downward, you can see. All right, and we can save this. And now our player has a camera attached to it. Okay, if we close this and we go back to our level, let's just save all. And let's hit play again. All right, here's our cube still here. Now we don't actually see the camera on it because we are still using our main camera for the game. So next up, we're going to build out a game mode, which is like a manager. And there we'll set that we want our player to be the player blueprint. Now we want our camera to be the camera that's associated with this player blueprint. So join me in our next lecture. We'll continue this project and we will build a game mode. Hello everyone, and welcome back to our course. In our previous lecture, we added a camera to our player blueprint. Now in this lecture, we're going to build out a game mode to actually specify that this player blueprint is what we want to be the main player and its camera to be the game's camera. All right, so let's close our blueprint and go back into our content browser. Here, we're going to create a new blueprint. So let's hit the add button and we're going to select blueprint class. Here, we are going to select game mode base as the type of the blueprint. This will be its parent class, which means it can use functions and variables from this pre-made Unreal base class. This is like a game manager or a game controller. So click on that and you now have this new blueprint. Let's just right click and we're going to rename it. We're going to call this our custom game mode. All right, you can hit enter and here we go. Now we have this new blueprint. Double click on it to open its blueprint editor. All right, here we go. We now have, as per usual, all of our windows of a blueprint. Let's go to our details window, and here we can set different properties, like different classes. We want to focus on this classes property because here, this is where we can set our default pawn class, otherwise known as the class used to represent a player. The default is the default pawn from Unreal, but if you click on this drop-down menu, you can actually select your player blueprint instead. So that is going to specify that the pawn for this game, for every player, by default should be our custom player blueprint instead of just a default pawn. All right, and let's go ahead and compile and save this game mode blueprint. Then we can close it. Now, we just created this blueprint, but how do we actually put it into action? Do we drag it into the viewport? How do we actually enable this game mode to be the manager of the game? Well, for that, we're going to go to the World Settings window, and we're going to set our game mode override here. We have none because we're not by default overriding any game mode. But if you click on this, you can select your custom game mode. So let me search here, custom. There we go. And I'm going to select my custom game mode to override the default game mode. All right, so there we go. We've now defined our game mode, and this time our camera for the game is now going to be the player's camera. So let me just save everything, and I am going to hit play. And look at this. My camera view has actually changed. All right, so now I'm going to just be able to move around in my game. You can also escape. Well, I currently can't move actually anymore because I've now changed my default pawn. So I actually can't even move my camera anymore. I can just drop down, okay? I can't look around anymore. The reason being that we haven't actually enabled user input yet. We'll do that next. But you'll notice here we now have 2 cubes or 2 players in the game every time I hit the play button. All right, so if I want to change this, if I want to just have the 1 cube, then just take this existing cube and just delete it. Go to the World Outliner and just hit the delete key on your keyboard. This is just because we no longer actually need to have that blueprint in the game for testing. It will be spawned whenever I hit play. The reason it's spawned whenever I hit play is because it's now my default pawn inside of my custom game mode, and my custom game mode is overriding the default game mode. So those are the 2 steps you have to take to change the game mode. Awesome. All right. Join me in our next lecture. We're going to continue this project, and we're going to continue by building out user input so our player can actually move around, they can jump, and then they'll have to run around a platform, avoid the death zone in order to collect the target so they can move on to the next level. I will see you in the next section. Hello everyone, and welcome back to our project. In the previous lecture, we learned how to create our player and how to make that player the default pawn that will be spawned every time play is hit. We also attached a camera to the player to follow around so we can follow our player around. But how do we actually get the player to move? Well, that's what we'll work on in this section. We'll make the player movable and jumpable. All right, but first we have to enable user input. So we have to set up what input we want to allow to be received and then write the functionality for that input. Okay, so to set how we want to receive input, whether that's via the mouse or the keyboard or controllers, we are going to enter our project settings. So in the top right-hand corner, select Settings and choose Project Settings. This will pop open the Project Settings window. There are lots of different settings that you could change. For us, we just want to go to the Engine section and select Input here. Okay, here in the Input section, there are many different settings we could change. We're just going to focus on Input. This will allow us to enable getting input from our players in order to change the game. Here we have bindings, which can bind a key or a control button to some action and to some axis. An action mapping means that you want to just have a key press or a key release. An axis mapping allows for a continuous range of input. For example, movement would be an axis mapping because movement is continuous typically. If you wanted to do teleportation, that would be an action mapping, or jumping, because you're just looking at the key press and key release. All right, so let's create our bindings. Click on the plus button beside the action mappings to create your first action mapping and expand these little arrows. We're going to create an action mapping for jumping. So I'll call this jump, because with jumping, the player won't be able to fly. They'll just be able to jump once at a time. So that's why it's an action mapping. It's going to happen upon a key press or a key release. In this case, click here below jump to select what is the actual input you want to allow. So you have this long list of different types of input, from the gamepad, from your keyboard, from the mouse, all the way to virtual reality controllers. In our case, I'm going to search for the space key, and I'm going to use the space bar for jumping. Typically, you want to stick with controls that users are familiar with, because that way they won't have to learn a whole new input system just to play your game. Okay, and then we have axis mappings. This is where we're going to map the movement keys, moving forward, back, left, right. Okay, and you can either use the arrow keys or the WASD keys. Those are the most common keys for movement. So let's click on the plus button beside axis mappings and then expand these arrows. Let's start by creating a new axis mapping for moving forward and back. So I'm going to create here my move forward or back axis mapping. To move forward or back, that's typically the W or the S keys on your keyboard, or the up and down arrow keys. So select whichever one you want to use. I'm going to use W under the keyboard. The scale here is 1.0 because we're moving positively, which means we're moving forward. We need to add another property here. So click the plus beside move forward or back and select this time the S key on your keyboard, so under the keyboard, and then set the scale to -1, which means that we can use the S key to move backwards. So we have two different keys here under the same axis mapping because one is in the positive direction and one is in the negative direction. Let's do a similar thing for moving left and right. And you don't have to set diagonal movement because that will just be enabled by default. If you have forward and back, left and right, you can do both at the same time as well. So I'm going to hit the plus button beside axis mapping to make a new axis mapping. And I'm going to call this move left or right and hit enter. Then I'm going to select what I want to enable input from. I'll do the keyboard again. This time I'll do the A key. So let's just type in A and then toggle close the gamepad because we want to go to the keyboard. The scale for A is going to be -1 because the A key is for moving left. Let's add another button here and let's select this time the D key under keyboard, and that is going to be for moving to the right, so it is a positive scale value. You don't have to save the settings, they'll be saved by default. And this will allow us to use these keys for movement. No other keys will be enabled unless you actually specify them here because we're using our own custom player. All right, now that we have our keys set up, we have to actually write the functionality to move them around. Because although we created the mappings, we have to actually create the functionality. These jump, move forward or back, those are not recognized by Unreal. We have to set that up ourselves because we're building this project from scratch. So join me in our next lecture where we will build out the blueprint functionality for movement. Hello everyone and welcome back to our course. In the previous lecture, we set up which of the different keys on the keyboard we want to use for input. And in this lecture, we are going to actually write the blueprint functionality for that movement. All right, so let's go into our content browser and let's open up our player blueprint class here. And let's go into our event graph. Here in the event graph, we are going to write the functionality that is going to allow for taking those keys on the keyboard and being able to move our player. All right, so let's start by using one of those inputs that we enabled in the previous lecture. Inside of our blueprint here, we can just delete all of these default nodes, and let's right click and create a new node. Here I'm going to search for input axis, and specifically it'll be that one that we made called move forward or back. Okay, here we're going to select under axis events, not axis values, because we're listening for an event, and that event is when our player wants to move forward or back. The reason this is called move forward or back is because that's what we called the input binding, that mapping, in the previous lecture. So I'll hit enter here, and that is going to create here for me input axis, move forward or back. Okay, now is where we write the functionality. So here I am going to drag off another node, and I'm going to write the code to move my player forward or back. So I'm going to drag this off, just click, hold, and release. And here I am going to call the function add movement input. All right, and select this bottom one under input. This is going to allow us to move a pawn. We have 4 arguments to this function: the target, which in this case is just self because it refers to the player, because that's what we're trying to move. We have the world direction, which we're going to have to grab from our player, which refers to what is the player's local direction. So that way you can actually move in your local forward direction instead of in the global forward direction. We have a scale value, and as well we have a force. So those are for setting how much we actually want to move. Okay, so here let's start by setting the world direction. I am going to just drag another node off of the world direction node, and here I'm going to search for the function get actor forward vector. Okay, so I'm selecting here this function because I want to get my player's forward direction. That's why the target is self. Self refers to just the current blueprint that this event graph belongs to, which is the player blueprint. All right, so we're calling this function so that way we can move in the direction that is relative to the player, because there's a global forward, back, left, and right position, but then there's a local forward, back, left, right position, and we want to use the local one that's local to every player. So that's why we need this as our world direction. Our scale value is going to be how much we're moving, and we can use this axis value. Okay, there we go. And that is going to allow us to move forward or back by either 1 or -1. Remember, it's 1 if we have a W pressed and a -1 if we have an S key pressed. So that is what that scale value refers to. Okay, and just like that, we have written out the functionality to move forward or back. You can compile this and test it out. Let's just close the blueprint. Then I'm going to press play. And this time, I can actually move forward and back by using my W and my S keys. And we move quite quickly there. Next, let's also enable movement left and right, which will automatically enable diagonal movement as well. So we're going to perform a very similar process to moving forward or back. Okay, so we are going to right click inside of our blueprint here, inside of the event graph, and this time we're searching for our second input axis, which was to move left or right. Make sure you're selecting the axis event and hit enter. And we're going to do a similar thing. We're going to grab this executable node and release it. And the function that we want to call is to add movement input again. Hit enter. And this time we're doing a very similar process, but we're just moving left and right. Okay, so there's a slight difference here in the direction because now we need the local right direction of our player instead of the local forward direction. The target is still the self because we're moving still the player. Let's drag off a node here off of world direction, and here I'm going to call get actor right vector. Okay, because the right is going to be considered the actor's local right. So that way we can then pass the axis value 1 or -1 as the scale value. Remember, 1 is if you press the D key, and that means we'll move in the actor's local right direction. We'll move by a scale of 1. If we press the A key, we'll move by a scale of -1 in the actor's local right direction. You can also add a force if you want to enable faster movement. All right, so let's save and compile this again. And then let's close this blueprint. And let's test out our game again by hitting play. And this time we can click inside of the viewport to enter the game. And look at this, we can now move forward, back, and left and right. This movement is quite fast, so let's slow it down just a little bit. To slow down the movement, we're going to go into our player blueprint again, and we're just going to change the speed. Here we want to go into the floating pawn movement component and go to the details. And here is where we can set our maximum speed of the pawn. Let's set this to something smaller, like, for example, 300. All right, then we can recompile and save. And if I hit play this time, I'm going to be moving a lot slower. I just have to click inside the viewport and then I can move. So depending on if you want your game to be action-paced or relaxing, you can set the pace of your player. Also, the faster they move, the harder it will be to move on a platform because you have to really pay attention. So perhaps you could start off slow and then have the player move faster as the levels get harder. Awesome, so now we know how user input works from scratch here in Unreal. I've just fallen off the platform. Let me reset my perspective by going to perspective and then cinematic viewport and then back to default viewport. All right, so now we've enabled user input for moving left, right, forward, back. Join me coming up in our next lecture. We're going to start learning how we can enable user input to jump. Hello everyone and welcome back to our course. In the previous lecture, we learned how to enable our player to move left, right, forward, and back, as well as diagonally, just with a combination of 2 keys. And in this lecture, we're going to begin enabling the player to jump. For that, first we have to know when the player is touching the ground and when they are not touching the ground. All right, so let's get started here. I'm going to go into my blueprint, that same blueprint, the player blueprint here. And I'm going to begin by creating a new variable inside of my blueprint, this window. This variable is going to allow us to store a piece of information or a piece of data. So hit the plus button beside variables, and we're going to call this our touching ground variable. This is going to be a Boolean. A Boolean variable can be one of 2 values, either true or false. All right, so then just go back to my blueprint and you'll see that touching ground variable. Next up, let's go into our event graph and let's create another event that we're listening for. So I'm going to right click and I'm going to search for event hit. This is under the collision group because this is going to get triggered whenever the blueprint object collides with a collider of something else. In this case, when the player blueprint collides with something else. All right, and here we are going to create a new function to write all the jumping logic. All right, so for that, let's go ahead and build a new function, just because if we put everything into this one blueprint, it's going to get messy very quickly, or at least it's going to be a lot of different nodes. So instead, I'm just going to create a function for what I want to happen for the jumping logic. Okay, so to create a new function, here go into the Functions tab and hit the plus button. Here we can then give this function a name. Just click on the function node and let's change its name to, let's call this the jump function. Okay, then I'm going to just compile this, and if you go back to your blueprint, you'll see jump as a new function that you can use. Go back to the event graph window, and here we're going to drag a new executable node, and we're going to call our jump function. So this means that whenever there's a collision that is processed with the ground, we're going to call jump. I'm doing this so that way we don't have a bunch of nodes inside of one blueprint, but instead we have separate blueprints. Okay, so let's open up the jump blueprint, and here we'll write our functionality. First, I'm going to drag off a node and create a new branch. A branch is like an if statement, something that you can happen if a condition passes as true or if a condition passes as false. You can have two different branches going off. Here we want some condition to be passed as true. Now, what do we want the condition to be? The condition is that we're going to check the value of a hit normal. Okay, so I'm going to click on this function and go into details, and I need to create a new input for this function. An input means a value that is passed into the function so that the function can use it. So hit the plus button, and here we're going to create a new variable here called hit normal. And the type is going to be a vector. A vector is a series of values, by default 3. Okay, let me just save and compile this. Okay, and if you go back to your main event graph, you can see that your jump function now takes in this argument, hit normal. I'm going to pass this function, the hit normal, from the event hit. Okay, there we go. And here now we're passing the hit normal from event hit into jump. Now let's go back into jump here, and we're going to use that hit normal because now that we have actually passed it as an argument, we can put it to use. So whatever value is passed in here, we can use it. And what I'm going to use it for is for checking equality. So here I'm going to create a new node, and it's going to be the equal node. So type in here equal, and we're using the equal operator, which allows us to check for equality. Okay, there we go. And in this case, what am I checking is equal. Well, I'm checking the hit normal, and then I can check it against some value, x, y, and z. In this case, I'm going to check here x, y, and z if z value is 1. Here we're checking if the object we hit has a collision normal, which is the direction the collision point is facing, of up. If it does, that means we're standing on something, and the only thing we could stand on is the ground or the platform or another object. So we're just checking if we're standing on something. If the hit normal of what we collided with has a z value of 1, that means its collision point is facing up. All right, so these are the two values that we're checking. Okay, and if this passes as true, this equality node, its result will be true, so we can pass it as the condition to the branch. This equality node, it's going to return true or false. It will return true if the hit normal equals this value. It will return false if the hit normal does not equal this value. And then we can use those two possibilities to create this branch statement, which will run if its condition is true or if its condition is false. It can run two different flows. Let's start with the true flow. Okay, here I'm going to create a new branch, and I'm going to call my set function for my ground variable. So set touching ground. This is a setter, which means you can change or mutate a value of a variable, in this case touching ground. And in this case, we're going to mutate touching ground to set it to true, because if this condition has passed as true, if the hit normal does equal this node value right here, this vector 3, that means we are touching some kind of ground or platform. We are standing on something. Otherwise, we're falling through space or we're jumping around. All right, because I only want to enable jumping if we're actually standing on the ground. Otherwise, the player could fly. Okay, so we're only setting touching ground to true if this condition passes as true. If the condition passes as false, then we're just going to leave everything as per usual. We don't even have to do anything because touching ground has a default value of false. And remember, the jump function is going to be called whenever the player collides with something. Let's go ahead and save and compile all of our code here. Currently, we haven't actually written any logic to actually force the player to jump. We've just specified the conditions that must be true for jumping to be enabled. The player must be on the ground. So join me coming up in our next lecture. We're going to build out the actual movement of the jumping itself. So I will see you in the next lecture. Hello everyone and welcome back to our course. In the previous lecture, we built out our jumping conditions, these conditions that must be true for jumping to be enabled. Otherwise, our player could fly. Now, in this lecture, we're actually going to write the jumping movement logic. All right, so for this, let's go back into our blueprint, the player blueprint, and we're going to start by creating a new variable here in the blueprint. Let's hit plus here, and we're going to call this the jumping amount. I'll call this jumping amount. All right, and you can make this an integer or a float. All right, and there we go. Now, if you go back to my blueprint, you'll see that variable here inside of the list. We have now jumping amount. Okay, next up, let's go ahead and listen for the input action that is jumping, which is the space key. And let's write the logic to actually do the jumping. Okay, so in this case, we already have a jump condition. Let's go back into the main event graph here. All right, and here we are going to make another listener or another event. All right, so I'm going to just right click here. And this time the event will be another input action, but this time the input action for jumping. So hit enter, and we have this next input action. We can specify what we want to happen when that key associated with this input action is either pressed or released. Okay, so let's do pressed in this case because we already have the conditions set up that make sure that we only allow jumping if we are indeed not jumping currently. Then let's create a function here. So I'm going to just create another function, and this is going to do the jumping movement. So let's click on this function and let's give it a new name. The name is going to be the jumping movement, or you could do perform jump. Okay, here we go. We now have the perform jump function. Then back in my event graph, my main event graph, I'm going to make a new node that will run when the jump key is pressed. And the node is going to call perform jump. All right, then let's go into perform jump. So that way we have everything separated into different blueprints. We don't need to have it all in one blueprint. We just have multiple small blueprints that are working together. Okay, so let's go into perform jump here. How do we actually enable our player to jump? Well, first we must check that the player is indeed touching the ground. So I'm going to drag a new node here and I'm going to create a branch. The condition here that must be true is going to be checking the touching ground variable. If touching ground is true, then this branch will return true. If touching ground is false, the branch will return false. The reason we need this is we can only jump if we are currently touching some ground. And we wrote the logic for checking that inside of the jump function, to jump or not to jump. Okay, so here inside of perform jump, if the jumping conditions or touching ground is true, let's perform the jumping action. In this case, it will be to add force to a static mesh. So I'll hit enter and we now have this add force function. The target is a static mesh, referring to the static mesh of this blueprint. Then we can also pass in a force value. For the force, we need the force to be the value of our jumping amount. And also, we have to specify a direction and multiply the two together. Okay, so we have to specify the direction because we want to move up. Otherwise, we're just moving. If we just put a force here, we would just be moving in one or more of these axes. Okay, so I'm going to here first grab the vector up, all right, and hit enter using the vector up function. Then here I'm going to multiply this. So I'm going to right click in the event graph and type in multiply. I want to multiply my vector up by my jumping amount. So let me just drag these over here and let me make a reference to my jumping amount just by right clicking and typing here jumping amount and using the getter just to get its value, not to set it. And then you can drag jumping amount to the multiplication node, and the node will adjust to fit the data types. The results of that we're going to pass as the force. All right, so now we have our force. So that way we're always using vector up multiplied by jumping amount to create a force. We can also specify that we do want the acceleration to change, which means that force is taken as a change in acceleration instead of a physical force. That's because we're not including mass in our game. All right, and then as well, when this is all finished, when a jump has been performed, we need to set touching ground back to false. All right, because that means that we are indeed jumping. Because if we have jumped, we're no longer touching the ground. So I'm going to add another executable node here, and I'm going to here set the touching ground variable, and I'm setting it to false just by not selecting this checkbox. All right, and there we go. This is how we can write a blueprint to have our player jump. One thing we do have to set is the jumping amount, because you'll remember we made that variable jumping amount, but we didn't actually give it a default value. So let's give it a default value of 50,000. Might seem like a lot, but you need a lot for forcing our player to jump, because we're not using mass. We're not taking that into account. All right, now let's compile and save this blueprint, and let's test out this jumping movement. I'm going to press play, click in the viewport to get control, and then look at this. Now, if I hit space, I can jump around.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.